Another way in which scientific notation can make our lives a lot easier is in operations like multiplication and division with numbers in scientific notation. So I have two examples here. What if we want to multiply 6 times 10 to the 5 times 2 times 10 to the 4? Or what if we want to divide them, 6 times 10 to the 5 over 2 times 10 to the 4? So each of these, multiplication and division, have their own rules or their own recipes in which we can solve this in a very easy way. So if you remember from the previous video, every scientific notation number is a single number, or a number with a decimal point, which we can call A, times 10 to the B. Right? So if we have two numbers and we want to multiply them, we can call this A1 times 10 to the B1 times A2 times 10 to the B2. So A and B are just numbers. And we want to know how to multiply something like this. So the easy way to do this is to divide the problem into the A's and the B's. So maybe let's use this color, and the B's. So what you do first is that you multiply the A's and you stop worrying about anything else. So you do A1 times A2. That is going to give you the new A. And then you do times 10 to the, and to get the new exponent, you add the exponents. So you add B1 plus B2, and that is your new exponent. Yeah, and for division, it's basically the same thing, but subtracting instead of adding. So our example would be A1 times 10 to the B1 over A2 times 10 to the B2. So again, the only thing we divide is the A's. So we would get A1 over A2, and then times 10 to the B1, and then we subtract B2 because we're dividing. Yeah? So maybe these formulas help you out, maybe they don't, but in general you just need to remember that you need to add the exponents when you multiply and you need to subtract the exponents when you divide. So how would that look for these examples that we had to solve? So what we do here is that we only care about the 6 and the 2 to multiply. So 6 times 2 is 12. So this is going to be equal to 12. And then we multiply times 10 to the, and we have a 10 to the 5 and a 10 to the 4. So we add the 5 and the 4, and that'll give us 9. So we get 12 times 10 to the 9. So we're almost there, but if you can remember from the previous video, the number here needs to have a decimal point. It can't be a 12 without a decimal point. It has to be 1.2. So we're going to have to convert this to 1.2 times 10 to the something. But it's not 9 again, because now we move the decimal point one more place. So because this number 12 is bigger than 1.2, then the exponent has to be smaller so that it's the same number to compensate. So since we move the decimal point 1 to the left, we subtract 1 here and we get 1.2 times 10 to the 8. If you put this in the calculator, surely you're going to get 1.2 times 10 to the 8. So that would be the solution for this multiplication. And what about the division? So again, we only divide the A's, the first number. So 6 over 2 will give us a 3. And times 10 to the, and we subtract the exponent. So 5 minus 4 gives us 1. So this is just, well, we can leave it like that because we only have one number here. So it's 3 times 10 to the 1. So actually we're going to get 30, basically. So that's how we do that. We can do exactly the same thing with negative exponents. So maybe we have, let's say, 1 times 10 to the negative 5 times, I don't know, maybe 4 times 10 to the positive 7. So what we're going to do here is, again, multiply only the first part. 1 times 4 will give us 4. And times 10 to the, so because we're multiplying, we add the exponents. Minus 5 plus 7 is actually minus 2, because it's the same as subtracting positive 2. Minus 5 plus 7 is the same as subtracting 5 from 7, so we will actually get positive 2. So it doesn't matter if it's a negative number or a positive number, you just add the whole exponent. So negative 5 and 7 will give us 2. So that will be our answer, and we don't have to do anything else. Now let's do it as a division. So we have 1 times 10 to the negative 5 over 4 times 10 to the 7. So we divide only the number. 1 over 4 is 1/4, which in decimal, if you put it in your calculator, if you remember, it's 0.25. So we're going to get 0.25 times 10 to the, and now we subtract. So don't get confused with the signs. It's just the first number minus the second number. So we're going to do negative 5 minus 7, which will give us negative 12. So the answer is 0.25 times 10 to the negative 12. I'm going to erase this here. But again, this first number, if you remember, should be between 1 and 9, not a 0. So it's not exactly in scientific notation yet. So for this one, we need to move the decimal point 1 space here to get a 2 in front instead of a 0. So we're going to get a 2.5. Yeah, just moving this to the right. And because we made this number bigger, we need to make this one even smaller so that we maintain the same number. So now, instead of times 10 to the negative 12, it's 1 less. So 1 less than negative 12 is negative 13, right? Negative 13. So remember negative numbers, just remember how to use them so that you don't get confused. But in general, it's just adding the whole number, the whole negative or positive number, subtracting the whole negative or positive number. And if you get a number that is not between 1 and 9, like here where we got a 12 or here where we got a 0, you need to move the decimal point either to the right or to the left to make the first number a number between 1 and 9. So here we had to make the number smaller. Oh my god, I think I made a mistake. Yes, we had to make the number smaller, so we need to make this one bigger to compensate. And here we made the number bigger, so we had to make this one smaller to compensate. Yeah. So that is how to multiply and divide numbers in scientific notation.